Welcome to the DIY Honda Garage channel. The error code P16BE indicates a malfunction in the starter cut relay 1 of the 2011 to 2017 Honda Odyssey. The starter cut relay is an essential component in the vehicle's starting system, ensuring proper voltage is supplied to the starter motor. Its primary role is to prevent engine startup if any faults are detected, thereby protecting the vehicle from potential damage or malfunction. This relay is located in the driver's under-dash fuse relay box. When there is an issue with this relay, it can lead to starting problems or even prevent the engine from starting entirely. To effectively address this error code, comprehensive diagnostics must be undertaken to identify any underlying issues with the relay or associated components. The starter cut relay 1 is a critical component designed to manage power flow to the ignition system of your Honda Odyssey. It is situated within the driver's under-dash fuse/relay box, which is generally accessible once you remove the cover. The relay's primary responsibility is to cut power to the starter when certain fault conditions are detected, thereby preventing the engine from starting if a problem exists. This function is crucial for maintaining the vehicle's overall reliability and safety. If the relay fails or exhibits issues, it may not signal the starter motor appropriately, leading to potential starting failures. Understanding its location and function is vital for troubleshooting DTC P16BE effectively. Several factors can trigger the P16BE error code, with each carrying significant implications for vehicle operation. A faulty starter cut relay 1 is the most common cause and may prevent the relay from functioning correctly. Additionally, poor connections or loose terminals at the relay or the powertrain control module, PCM, could also lead to signal loss or interruption, exacerbating the issue. The PCM, responsible for overseeing engine functions, may also malfunction, affecting relay operation. Each of these components plays a critical role in the starting system. Hence, identifying the exact cause is vital to resolving the error efficiently. Addressing these potential issues promptly will facilitate a smoother troubleshooting process. Symptoms associated with DTC P16BE can vary, but typically involve the engine failing to start altogether. It may also present intermittent starting issues, where the vehicle starts occasionally but fails at other times, leading to increased frustration and potential strain on the engine. A common sign of relay malfunction is the absence of a clicking sound from the starter cut relay when attempting to start the vehicle. This could indicate that the relay is not engaging sufficiently to supply power to the starter motor. Recognizing these symptoms can help in correlating them with the diagnostic issues identified by the DTC code. Being aware of symptoms can also assist owner-operators in making informed decisions on when to seek professional help for resolution. The initial step in troubleshooting DTC P16BE involves setting the vehicle's ignition to the on position, specifically the second position, referred to as on 2. This action energizes the electrical systems without starting the engine, which allows for diagnostic testing. Before proceeding, it's crucial to record all freeze frame data and onboard snapshots of the system, as this provides a historical view of the vehicle status at the time the fault occurred. Next, review any general troubleshooting information which may provide additional context or considerations unique to the Honda Odyssey model. Accurate documentation ensures that all data is captured for future reference and helps streamline the troubleshooting process, leading to better diagnosis and repair precision. In this second step, you will utilize the Honda Diagnostic System, HDS, to clear the DTC from the vehicle's memory. Clearing the code is essential as it resets the system and allows for a fresh evaluation of the vehicle's operational state. After initiating this process, it is vital to wait approximately 5 seconds to allow the system ample time to complete the clearing function. This brief pause ensures that all related systems are reset appropriately, which is crucial for accurate testing in subsequent steps. Following this step, the vehicle will be ready to determine if any underlying issues persist or if the initial fault was a temporary condition. As always, proper use of the HDS is key in maintaining diagnostic accuracy. During troubleshooting step 3, you will begin to check the voltage levels of the starter cut relay using the HDS. It is crucial to ascertain if the relay is receiving an adequate voltage indication of 3.0 volts or more. This measurement confirms whether the relay is functioning within operational thresholds. If the reading indicates 3.0 V or more, it implies the relay is receiving the correct power supply, and you can proceed to the next troubleshooting step. Conversely, if the reading is below this threshold, it suggests an intermittent failure in the system. You will need to check for any possible poor connections or loose terminals linked to both starter cut relays and the PCM, which might be disrupting the current flow. This step plays a key role in isolating the fault to either the relay itself or wiring issues. In step 4 of the troubleshooting process, you will need to physically remove starter cut relay 1 from the driver's under-dash fuse box. Begin by locating the fuse box, which is generally situated on the lower left side beneath the dashboard. Once identified, carefully pull the relay out by grasping it firmly and pulling directly upwards. This removal is critical to isolate the relay from the circuit, enabling more in-depth testing of the component itself. It's important to handle the relay carefully to avoid damaging the relay pins or the socket from which it is removed. After successfully extracting the relay, you can proceed to check its operational status, ensuring you are on the correct path to addressing the P16BE error code. Step 5 replicates the voltage check from Step 3, but now focuses on the removed starter cut relay 1. By using the HDS again, you check if the relay itself indicates a voltage of 3.0 V or more. This step helps in determining whether the relay functions properly after being isolated from the circuit. If the relay maintains the appropriate voltage level, the next step should be taken to further check other components in the circuit. However, if it falls below the expected voltage threshold, it indicates the need for immediate replacement of starter cut relay 1. Understanding the relay's behavior in conjunction with the previous steps ensures you are systematically addressing the issue at hand. In the final troubleshooting step, you will measure the voltage at the starter cut relay connector. Use a multimeter to check the voltage specifically between terminal number 1 of the 4P connector and the body ground of the vehicle. This measurement assesses the relay's capability to receive voltage from the system. An appropriate voltage signal at this point suggests that the relay circuitry is intact and the relay can function appropriately. If the measured voltage is significantly lower than expected, it may indicate an issue with wiring, grounding, or possibly with the PCM that needs repair or further examination. Completing this step effectively ties together all previously acquired information, giving you a full understanding of the relay's operational status. After completing the necessary repairs indicated through the troubleshooting steps, it is crucial to conduct a final repair verification. This process involves running the vehicle to confirm that the replacement or adjustment has resolved the P16BE issue. It's advisable during this phase to monitor the vehicle's starting behavior and check for the absence of the DTC reappearing. Additionally, you may want to utilize HDS to ensure no new fault codes have been stored, confirming that the system is now functioning normally. This verification is essential to guarantee that the repairs have effectively addressed the malfunction and that the vehicle is now operating as intended, providing peace of mind to both you and the vehicle owner. To prevent issues like DTC P16BE from recurring in the future, it is important to implement a schedule for preventive maintenance. Regular inspections of the starter cut relay 1 and its associated wiring should be included in routine vehicle checks. Ensuring that connections are secure and free from corrosion can significantly extend the lifespan of electrical components. Periodically cleaning electrical terminals helps maintain a low-resistance path and can prevent intermittent issues. Educating vehicle owners about attending to electrical systems during routine service can also mitigate risks associated with relay failures. By focusing on preventive measures, technicians can ensure the reliability and efficiency of the Honda Odyssey's starting system over time. In summary, addressing DTC P16BE, which indicates a malfunction in the starter cut relay 1, involves understanding its essential role in the vehicle's electrical system. The troubleshooting process needs to be methodical and thorough, ensuring each step accurately isolates potential failures. Symptoms can vary, including starting failures that signify the need for a diligent examination of the starter cut relay circuit and related components. To safeguard against future issues, routine inspections and maintenance practices are advisable. By incorporating these strategies into vehicle care, technicians can significantly enhance the performance and reliability of the Honda Odyssey, providing an optimized ownership experience while minimizing potential breakdowns or inconveniences. Please like and subscribe to the channel. See you next time.